So for today's notes, I just want you guys to do the old simple do now, which is find the zeros of this equation. And if you get stuck and you're like, oh, I'm not sure, there's a question after this. So you can say, if you're stuck, what is making you stuck on this problem? If you're not, go ahead and solve it. Pause the video if you haven't, and play it when you're done. And you should be stuck on this problem. It's not a simple problem for us right now, at least. And what's making you stuck? Well, every single other problem before now has given us like a factor or a zero. We're not going to be given a factor or a zero after today. So why are you stuck? Well, I don't know a zero of the function. So how do I know what I'm supposed to use for synthetic division or long division? That's what we're doing today. And that's what we call the rational root theorem. So what should I know by the end of the day? I can state the rational zero theorem or rational root theorem. Root and zero, same thing. I can use the rational zero theorem to find all the possible rational zeros. So we're going to find all the possible zeros it can be, and then we're going to find the actual zeros. So we're going to first list all the possible rational zeros, and then we're going to use that to actually find all of these zeros using synthetic division or long division if you want to. But I would do synthetic division because that'll be a lot easier and quicker. So let's go to the next page. So the rational zero theorem or the rational root theorem, you'll see it both alliteration, rational root theorem sounds a little bit better. But so if the polynomial p of x, and there's just any random polynomial, it's just in general form, has integer coefficients, and a of n cannot equal 0, or else that's not the highest degree, because it'd be 0 times that number, and a is 0, cannot equal 0, then every rational zero of p has this form. And where are we getting the p and q from? Well, it's right down here. So p has to be a factor of a0. So p is a factor of the constant. And q is a factor of the lead coefficient. And there's one more big thing here. It says p and q are integers. So we're going to have a plus or minus out here because it could be negative, it could be positive. So, and this is probably a lot to take in right now. Once we do one question, it's going to be like, okay, that makes way more sense to me. And then here's another way of saying it. Possible rational zeros right here. You take all the factors of the constant term. So all the factors of a0, which we said was p, right? And you divide it by every single possible factor of the lead coefficient, which is an. And that's what we said would be, q would be all the factors of an. So once we do one question, I'm sure there's a lot of people like, what is he talking about? We'll do one question. I think it's going to really make a lot more sense. So, and I want to stress also, these are all the possible or potential zeros. They're not all of the zeros. They're just the possible or potential ones. And we're going to want to break down the actual zeros from there. So let's first just look for all the possible zeros. So here we have, and we can show the rational root theorem as we do this, find all the zeros of f of x equals x to the third plus 2x squared minus 5x minus 6. So, first off, what I would do is I would list every possible value of p we could have. So, p is the factors of the constant. So, look at the constant, 6, or you can say negative 6. So, all the factors of 6, we have 1 and 6. So, 1 and 6, and 2 and 3. So, I'm just going to write them in order because it's easier for me down the road to write the factors in order. So all the factors of 6, 1, 2, 3, and 6. And then list all the factors of q. And q is the factors of the leading coefficient. So the leading coefficient here is just 1. Oh, that's the best one. It's just 1 because the only factor of 1 is 1. So all the potential zeros we could have it would be p over q. So we divide every factor of p by every factor of q. And this one's a little bit easier one because q is just equal to 1. So we would have 1 over 1, which is actually, I'm just going to write that as 1. So we have 1. And then don't forget, it says they're integers. So it can either be positive or negative 1. And then we continue. So we use P in this Q. Now let's use the next P value, the next factor of the constant, which would be 2. So then it would be plus or minus 2 over 1, which I'm just going to write as 2. And we do the same thing for 3. We do plus or minus 3 over 1, which would just be 3. And then plus or minus 6 over 1, which is just 6. So those are all my potential real zeros. So if you want to list that out, all potential real zeros, you don't have to do this, by the way, I'm just doing it for just this one, would be negative 1, 1, negative 2, 2, negative 3, 3, negative 6, and 6. So those are all of the potential real zeros we can have. So from there, we just have to test to see which ones are the actual zeros. So if I were, think about for like 30 seconds, pause the video. How can I figure out which ones are the zeros? Well, I can just try synthetically dividing the zeros and see if I get a factor of, remainder of 0. So if I don't get a remainder of 0, that's definitely not going to be a 0. We have to go and try a next one. So I'm going to try what I would recommend for, finding the zeros is do the easiest ones first. Because if you find so I think 1's the easiest one to do because 1's so easy to multiply and add. So I'm just going to try 1 first. And I'm going to synthetically divide. So my coefficients are this. So I bring down the 1 times 1, and I'm just going to synthetically divide right here. Add vertically, 1 times 1 is 3. Add vertically, 1 to negative 2. Oh, look at that. We don't get a remainder of 0. So I know 1, not going to be a 0. So I tried 1. Don't have to try that again. And then you could try whatever you want next. I would save 6 for the last because that's the largest number. I try to go the smaller numbers first to multiply at least. So I'm going to choose, you could choose 2. I'm going to choose negative 1 next just because, 1 and negative 1 are pretty easy to work with. So let's see if negative 1's going to be a 0. So I put negative 1 there. My coefficients from the original equation. Do the synthetic division here. 1. 1, add across, negative 1. Oh, look at that. We get a remainder of 0. So what does that tell us about negative 1? That tells us it's a 0. So we have 1 0 of negative 1. And now look at this. This will be x squared plus x minus 6. We have a quadratic now. So we can do what we have been doing and just solve this quadratic. So that'd be x squared plus x minus 6 equals 0. It's factorable. That would be x plus 3 times x minus 2 equals 0. T-chart, you should get x is equal to negative 3 and x is equal to 2. So my answers would be negative 3, negative 1, and 2. So that's how we would go about finding the zeros when we're not given them, which, by the way, you're not going to be given them a whole lot from here on out. So you have to use the rational root theorem to figure out what the real zeros are. And honestly, sometimes you're going to get unlucky. Back when I was learning this, I sometimes would try 8 of the numbers, and I still wouldn't find the 0 until the 9th one. It took me forever. And so I learned the best way of doing it so it doesn't take you guys forever is don't just choose random numbers. Don't choose I'm going to start with negative 6 because why not? You could, but it's just so you don't take as much time as I took on some of those. I would always start with, the simplest ones to multiply first, so negative 1 and 1, and then I would go to negative 2 and 2, negative 3 and 3, and we have to do negative 6 and 6, do that at the end for synthetic division. So let's go on to the next page. on the next page. So here's one. Look at our lead coefficient. It's 15. So we're going to have some factors for Q and some factors for P here. So it says use the rational root theorem to find all possible rational zeros of f of x. First thing you want to do is list the factors of the constant and then list the factors of the lead coefficient. Because remember, back to the rational root theorem, we want to look at all the values that P over Q can be. So let's start. Remember, P is the constant. So P would be 2 or negative 2 if you want to think of it like that. So P would either be 1 or 2. And then Q would be 15, the factors of 15. So we could have 1 and 5 and, 1 and 15 and 3 and 5. So we have 1, 3, 5, and 15. So when we do every way we can write P over Q, remember it could be all the integer combinations. So every single one has a plus or minus. So we could have, actually take a second. I want you guys to figure out all the values of P over Q. Pause the video and play it when you're done. So we could have 1 over 1, this P over that Q. Oh, let me just write that as 1. And then we can also have 1 over 3, so plus or minus 1 over 3. And then plus or minus 1 over 5. So it's every single possible combination of P over Q. And then do the same things for 2. So plus or minus 2 over 1, which is 2. Plus or minus 2 over 3. Plus or minus 2 over 5. And then plus or minus 2 over 15. Now make sure there's nothing that overlaps. No, there's not. Like, for example, if you got plus or minus 2 over 6. I know we don't have that in this question, but you will later down the road. That's the same thing as plus or minus 1 over 3, so you don't need to write that again. But we'll have a question like that down the road. So now I want to find all of the zeros that I could potentially use for this. So I found all the potential zeros. Now I want to find the actual zeros I could use. So what's probably the easiest one to use here would be, I'd say 1. 1's always the easiest one. So let's try and synthetically divide 1 first. So here's 1. And then we have 15, 14, negative 3, and negative 2. And hey, if you guys want to do this, pause the video and just watch it once I get the answer, because you're like, I think I know this, feel free to just pause the video. So we're going to synthetically divide here. And why do we synthetically divide here? Well, I want to see if it's an actual zero. I know it's a potential zero. I don't know if it's an actual zero. So, and if it is a 0, the remainder is going to be 0. So I bring down the 15. 15 times 1, 15. Add, get 29. Then we get 26. 26. That is not a 0. So we know we can't use 1. I'm going to use, when there's fractions involved, I try and do the fractions last because it's easy to make mistakes with arithmetic with fractions. So I'm going to choose negative 1 next. I think 1 and negative 1 are the easiest to work with, and sometimes it's not going to be 1 or negative 1, then you got to try another number, but hopefully this works. So I'm going to try negative 1 and use the coefficients from before. Drop down the 15. That'd be negative 15 times, add, multiply, negative 2. And look at that, negative 1 is a 0. So that works. So our leftover quadratic equation from this would be 15x squared minus x minus 2 equals 0. I want you guys to pause the video, solve for the final zeros, and play it once you're done. So that is factorable, but if you didn't see it was factorable, go ahead and you do completing the square. Oof, that'd be rough with that 15x squared. But you could also do quadratic formula. We should get the same answers at the end, negative 1 over 3, 2 over 5, and then we got negative 1 before. And then that checks out because look, negative 1, I know that was a 0. a potential 0. Negative 1 over 3. That was a potential 0 that we got. So this is all working out so far. And then 2 over 5. Positive 2 over 5. That is a potential 0. So you also could have done synthetic division with those numbers. I wouldn't recommend it if we can do negative 1. But you would also get them to be zeros also. And if we want to write this in completely factored form, well, look at our factors. We had negative 1 was, look at our zeros. Our negative 1 was a 0, so that would mean x plus 1. And then we have our factors here also. It was 3x plus 1 and 5x minus 2. So that would be times 3x plus 1 times 5x minus 2. And just make sure you make it an equation equals f of x. And that's it. So, how we are going to be finding the zeros or factoring a polynomial if you can't do like a quick method like the AC method or factor by grouping. You have to use the rational root theorem to first find all the potential or possible rational zeros. And then synthetically divide the easiest potential zeros you have there. So that's why I chose 1 and negative 1 until you find a 0. And then if it breaks down to a quadratic, we can just factor it or use the quadratic formula to solve. If it doesn't, we're going to have to do synthetic division again, which I think is going to be like the one we have coming up here. So let's go to the next page. So on the next page, actually, you know what? I think you guys might be able to do this one. The only thing different about this one than the other one is it's degree 4. So that means we have at most 4 zeros. So you might need to synthetically divide to find 2 zeros for this. And then you can get a quadratic to find the 2 other ones. So what I want you guys to do is pause the video, try this one out, and play it once you're done, and we'll go over it. So here's what I got for all my potential or possible rational zeros. I don't know which ones they are yet, but which ones do you think I should try first for synthetic division? The easiest ones. I would do plus and minus 1. Unfortunately, when you did plus or minus 1, they didn't work out. So then I moved on to 2. And then there's a couple like key strategies here that I employed. So I tried positive 2 because if I think it's easier to work with positive numbers, that still didn't work out. So then I moved to negative 2. And when I moved to negative 2, here's where there's 2 strategies I want to make sure you guys are good with because this is going to save you a lot of time down the road. Trust me on that. So when I tried negative 2, so right here, oh, this worked out. It was a 0. Great. And then what was left over was the coefficients of 1, negative 7, 9, and 5. So strategy number 1, I would rewrite this on the side because maybe, it doesn't work in this case, but maybe we could factor this and then save us 5-10 minutes. So if I look at this, can I factor by grouping? Unfortunately, we can't. So it didn't save us time on this, but it might in the future. So that didn't work out for us, but always try that. And then this is the second one. And this is tough to see if you don't do this. This 0 of negative 2 could have a multiplicity of greater than 1. So at negative 2, this polynomial could be bouncing. We don't know that without looking at the graph. So, which we're not doing yet. So what you should do in order to you can't just cross off negative 2 yet because that could be more than 1 0. Try negative 2 again. So I tried negative 2 again with the new coefficients, and well, it wasn't another 0. So it only had a multiplicity of 1 there. So we just use negative 2 once, and then keep going from there because we can't factor this by grouping. So we have to keep going and try more zeros. So the next one on my list was 5 and negative 5. So I tried positive 5. Oh my gosh, look at that. It worked out. We got a 0. So it gave us a quadratic equation that unfortunately was not factorable. So that's why I used the quadratic formula. And I found my zeros to be 1 plus or minus radical 2, in addition to the zeros we found through synthetic division. So here was my answer. And factored form, well, think about factored form. So all the completely factored stuff would be, well, so if the 0 was 5, that would be x minus 5. So that would be one factor. If 1, 0 was at negative 2, that would be x plus 2. And then the other completely factored factor would be x squared minus 2x, because we couldn't actually factor that. So that was our other factor. So those would be our three factors in this case. So it would be x plus 2, x minus 5, and then the x squared minus 2x minus 1. Make sure you guys write equals f of x. If you don't do that, it's not an equation. It's not the completely factored form of the equation. So you need to write that. All right, let's go to the next page. So for this next one, I want you guys to try this one by yourselves, but if you get stuck, unpause the video, and I'm going to go step by step, and if you get to the step where you were stuck on, and once you overcome that step and make sure you're good with it, I would pause the video again, and then keep going. So pause the video now and give it a shot, and play it once you're done. So it says find all the zeros of f of x equals x to the fourth minus 6x squared minus 8x plus 24. First thing you got to do is we have to list all the potential zeros first. So we write down p, we write down q, and then it's nice when q is just 1 because it's just what p is going to be, because you're just dividing it all by 1. So those are all our potential rational zeros. Next step is to do what? Well, we have to figure out which ones are actual zeros. We got the potential ones, but we don't have the actual ones yet. So let's synthetically divide. I ran out of room. I did honestly try 1 and negative 1 first, but then I realized 1 and negative 1 weren't zeros. So then I tried 2, and 2 worked. Look at that. It has a remainder of 0. But before you go on to keep checking, remember the 2 strategies I want you guys to do once you find a 0. Is A, just bring off to the side those coefficients and see if we can factor the cubic, in this case, that it made. Yeah, unfortunately we can't. Sometimes you will save you a bunch of time. So the next step I want you guys to do is don't move on to another factor, because we could have a multiplicity higher than 1 for the 0 of 2. And if we do, and you guys skip 2, which you might have done, and you might have played the video right now to check this out. You probably took a lot of time checking plus and minus 3, plus and minus 4, plus or minus 6. But you got to check 2 again, because there's a multiplicity for the 0 of 2. It happens twice. So make sure you check that multiplicity out. And now we have a quadratic. So now we have x squared plus 4x plus 6 equals 0. So that's unfactorable. We have to solve by using the quadratic formula, which we do. So our answers would be 2. And make sure you note that there's a multiplicity of 2, so it happens twice. And then also negative 2 plus or minus I radical 2. And if I were to write that in completely factored form, well, we have a 0 of 2, so that would be x minus 2. But it happens twice as a multiplicity of 2. So that would be x minus 2 squared, because of the multiplicity of 2. And, well, x squared plus 4x plus 6 was unfactorable. So that's why that is that's in the factored form. So moral of the story, I know there's going to be some of you guys that skipped 2 the second time and didn't check it again for the multiplicity. Moral of the story, if you guys did that, once you get the 0, check it again to make sure it's not a multiplicity, because you're going to check a bunch of other numbers, and it's not going to work out, and you're going to waste a lot of time. So let's go on to the next page. The next page, I think is the last page before the success criteria, is just the checkpoint. So I want you guys to take your time on this. Find all the zeros for each polynomial. And make sure it's in completely factored form also when you're done. So zeros and completely factored form. And pause the video and play it once you're done. So here's what I got for my answers. A lot of work. So 1 and -1 didn't work for number 1, but -3 did. And then it might take you a little bit, but then 5/2 worked for the other 0. So after you get that, we now have a quadratic. And then once you get a quadratic, save some time. Now we can just do the quadratic formula or factor if it's factorable. We had to use the quadratic formula. So here are my answers, and then here's my factored form. Mr. Shannon, why did you write this as x minus 5/2? Well, my 0 was 5/2. So that would be, the factor would be x minus 5/2. Then you could also say, Mr. Shannon, but what if can I write it as 2x minus 5? Yeah, you could, but wait, if you do it that way, what you're going to want to do is, you see this 2 this GCF of 2 that we factored out here, you can multiply that 2 into this factor if you want to, and then you can write it as 2x minus 5 here if you want to do that. Both answers are acceptable, so if you want to do that, go right ahead. It looks a little bit nicer, but you don't have to. So if you just want to keep it like I did in the beginning, that is 100% fine if you want to keep it like that. And then 2, a little bit nicer than number 1. 0 wasn't a fraction. It was 1 0 was at -1, and then I checked -1. Make sure you check -1. And then this was not factorable. Check -1 again. You got to make sure you check it again. And it didn't work. And here is the answer. And here is a completely factored form. And why is it x plus 2 squared? Well, there's a multiplicity of 2 at -2, so that's why it's x plus 2 squared. And you can see that also in our factored form up here. So that's it. I'll post the homework. I think it's part of the classwork, and that's it. Feel free to log on to the Google Classroom if you guys have any questions during the class period.